Now let us learn about another classification of signals known as deterministic and random signal. What is a deterministic signal? A signal whose physical description is known completely in mathematical form is called a deterministic signal. Deterministic signals are those signals whose values are completely specified in analytical form for any given time. Otherwise, a signal is said to be deterministic if there is no uncertainty with respect to its value at any instant of time. So thus we can say that a deterministic signal can be modeled as a function of time. This triangular signal, this rectangular signal, this Gaussian signal, all these are examples of deterministic signal because we have a mathematical function corresponding to these signals and which can be also represented in a graphical way. So these are known as deterministic signals. So as I have said earlier, deterministic signal can be modeled as a function of time. Here you can see that del of t with respect to time, and here it is pi of t with respect to time, and here it is g of t with respect to time. So all these signals can be modeled as a function of time. Now what is meant by random signal? A signal whose value cannot be predicted precisely but are known only in terms of probabilistic description is a random signal. Random signals are those signals that take random values at any given time and must be characterized statistically. Random signal occur due to some random phenomena that cannot be modeled analytically. The cause of the random signal is because of some random phenomena, so that cannot be modeled mathematically. This probabilistic description we use for analyzing this kind of signals include mean square value, variance, etc., which you have already studied in your statistics class. So the statistical characteristics include average values of the signal amplitude or squared signal amplitude, distribution of various probabilities involving the signal amplitude, distribution of normalized signal energy, power among different frequencies. All these kind of probabilistic or statistical characteristics can be used to analyze random signals. Now, why such kind of random signals occur? Random signals occur due to random phenomenon which cannot be modeled mathematically. For example, a random signal is a noise which generated in most of the electronic circuits. This may be due to some resistor. The reason behind this noise is the random movements and collisions of electrons and the thermal energy produced by these collisions inside a resistor. The noise signals from various sources like electronic amplifiers, oscillators, radio receivers, etc. are best examples of random signals. So when you study about communication, especially analog communication and digital communication, you can learn a lot about these kind of random signals because when the signal passes through the channel, it is affected because of this noise, and all these noise signals are modeled as random signals, and we are using different statistical and probabilistic characteristics to analyze such kind of signals. We can say that all practical signals are random to an extent. For example, here I have given a speech signal, also an ECG signal. All these are examples of random signals. We can approximate it to some mathematical models or equations, but if you take all the practical real-time signals, we can say that all these practical signals are random to an extent. The random signal can be viewed as belonging to an ensemble of a group of signals, with each signal in the ensemble having a different waveform, and each signal within this ensemble has certain probability of occurrence, and this ensemble of such signals is referred to as random process. So more about that you can study when you learn digital communication.